Austin, we just started this biomolecules in which we saw that carbohydrates initially defined as hydrate of carbons, and there was a general formula CxH2O whole Y, on which most of the carbohydrates are fit into this formula. This is your glucose or fructose, you can call it. But there was exception, or not every carbohydrates fit in the formula. Also, there are some compounds which are not carbohydrates fit in that formula. Like this is your acetic acid, which fits in the formula. This is your rhamnose, which is carbohydrate not fit in the formula. So there was another definition comes for this. First, please take the screenshot of this. Done. Austin. So after that, the formula comes out to be like this definition, and that is you can see aldehyde or ketone groups and hydroxy. Hydroxy, that means alcohol group in the compound. Then it will be carbohydrate. Polyhydroxy. The definition is like carbohydrate may be defined as optically active polyhydroxy aldehyde or ketones. That means in the compound you have aldehyde or polyhydroxy, many hydroxy groups are there, or ketone with polyhydroxy, or we can define it the compound which on hydrolysis gives such units. That means such units like polyhydroxy ketone or polyhydroxy aldehyde. That is your carbohydrate. Now there is some definition for different types of carbohydrates. Like some of the carbohydrates are sweet in taste, that are called sugars. Some of them are not sweet in taste, that are called non-sugars. Is that clear? Can you change the slide? Humam, Humam, are you there?
Yes, sir.
Okay. Can you change the slide?
1 minute. Yes, sir, you can.
The next point you can write with me. The most common sugar used in our home is named as sucrose. Named as sucrose. Whereas the sugars present in, you need to remember all this. In milk, which type of sugar or what is the name of the sugar present in milk? That is lactose. So you need to remember this. Let me know when you're done with this.
Done, sir.
Classification is based upon different criteria. So the first classification is based on hydrolysis. Based on hydrolysis. After hydrolysis of a compound, if you are getting one carbohydrate, that is called monosaccharide. If you are getting more than between 2 to 10, then it is called oligosaccharide. If you are getting uh, many carbohydrates, that is then it is polysaccharide. So I'm going to classify this. Just wait a minute. Yes. So here the first classification on the basis of hydrolysis, monosaccharide, monosaccharides. Then comes your second, that is your oligosaccharides. Then comes your third, polysaccharides. I will define each one of them. So what is monosaccharide? Monosaccharide, that means it doesn't hydrolyze. It is already in the shortest or simplest form. So the one which is does not hydrolyze. As for example is very important. There will be question directly write example of monosaccharide. So that is your glucose. It cannot hydrolyze. Fructose, it also cannot hydrolyze. Galactose, etc. Oligosaccharide, that means after hydrolysis produces 2 to 10 monosaccharides. 2 to 10 monosaccharides, that means it is oligosaccharide, monosaccharide units on hydrolysis. On hydrolysis. Okay. So like we can call it disaccharide, trisaccharide. That depends upon you. So let's say if you have after hydrolysis getting 2 units, so it will be known as disaccharide. Disaccharide, that means basically 2 units. For example, disaccharide example, we can write sucrose. Sucrose, wait a minute. Sucrose, maltose, after that we have lactose. And we can have triasaccharide as well. Trisaccharide. I'm going to write the short form. Trisaccharide. That means 3 units. And it's also example very important. That is raffinose. So this is your oligosaccharide. What about this polysaccharide? Many units you will get. So carbohydrates, which produces large number of monosaccharides, a large number of monosaccharide units on hydrolysis. Called polysaccharides. And here we can write the example: starch, cellulose. These are all polysaccharides. Glycogen and gums, etc. Let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Very good. So these polysaccharides are not sweet in taste. So we can write a point about this. So write a point about this. That is, these are not sweetened test. These are not sweetened tests. Hence, they are also called as non-sugars. So I think it's clear to all of you till this, right? Can I change the slide?
Yes, sir.
So this classification is based on hydrolysis. The first classification based on hydrolysis. The second classification that we have is based on reducing and non-reducing. Reducing and non-reducing. That means very simple. It is the one which is going to reduce. It will be reducing sugar. The one which is not going to reduce. It will be non-reducing sugar. So here I'm going to write reducing and here I'm going to write non-reducing. And the reagent that we are going to use, the reaction, we already studied in aldehydes. So the first reducing is your, it will reduce is tolerance test. Tolerance, do you remember? Reduces tolerance reagent, phalanx reagent, and Benedict reagent. Write it. These are all the reagent. Tolerance already we studied. Phalanx we already studied. But when we are going to Benedict and phalanx are almost same. And non-reducing are the one which does not reduce, don't reduce, or does not reduce. Tolerance reagent, don't reduce. Phalanx reagent or phalanx test, don't give. And Benedict. Please do write. For example, we can go for monosaccharide like glucose, fructose, and galactose, etc. They can easily reduce this all. This is the first example. Disaccharide like maltose, lactose, etc. Right. And here we can write sucrose, etc. It doesn't reduce. It is non-reducing. You will get the PDF. Please go through that. Very easy it is. The reaction I need to explain only. The rest is very easy. Are you done with this?
Yes, sir, done.
So see, already we know that the tolerance reagent in which you have silver in plus one oxidation state, in which it will reduce itself. That means it will act as an oxidizing agent. So when I'm going to talk about this tolerance reagent, this is basically ammonical silver nitrate. Ammonical silver nitrate, and it is, you can take AgNO3 plus NH4OH, or you can take Ag2O. That means the oxidation state of Ag should be plus one, or you can directly take Ag plus aqueous. Or you can take, this is basically, if you are going to combine them, you will get AgNH3 whole twice in the form of basically oxidation complex compound. So everywhere, if you are going to calculate, the oxidation state will be plus one, plus one, plus one, and here it is also plus one. What will happen if you are going to apply this to any aldehyde or ketone, and that aldehyde or ketone is going to reduce, basically carbohydrate is there, aldehyde, ketone, hydrate, aldehyde or ketone present in this carbohydrate, if it is going to oxidize, basically what happens if it is a reducing sugar, the carbohydrate will oxidize. That means the aldehyde or ketone will be converted into carboxylate anion. That means salt basically. And this Ag plus is going to reduce itself into Ag silver mirror, into Ag silver mirror. So we can write silver mirror, PPT. So write it.
Done.
Very good. Now we are going for practicing some questions. Just wait a minute. Just wait a minute. Please do this question. Any answers? You have got the PDF of this chapter, biomolecules. Mom, Austin, any answer? Fifth is wrong answer. Basic strength, as you know, that directly proportional to plus I. All are amine except if you are going to remove this. NH2 is common. So see, there is plus I effect. That means third is the most acidic, I think, right? There is no plus or minus I effect. There is minus I effect which decreases. So third, then comes first, and then comes the second. They asked about basic strength. As you know that basic strength is directly proportional to plus I, directly proportional to plus m, right? Omam, is that clear, Humam? Now, this question, if you are going to see which of the following reaction is appropriate, that means suitable for converting acetamide to methenamine. Acid S we generally use for two carbon, ethane. Acetamide, that means this is your acetamide, and you are converting this into methenamine. That means you can see in the product you have one less carbon. So this is your degradation. So Hoffman hypobromamide reaction, Stephenson reaction, carbolamine. So the answer will be Hoffman this hypobromamide reaction, and we also call it Hoffman basically bromamide degradation reaction. If you remember, are you getting my point? How you use this reaction with this amide? You are going to use Br2 in the presence of NaOH and heat, then you will be getting this along with NaBr, along with Na2CO3, along with in the solution there will be water. Is that clear, both of you? This is NCRT reaction, simple reaction. Everyone done with this? Eighth, any answer? The electrolytic reduction of nitrobenzene in a strongly acidic medium. Very simple it is. If you are going to react this, oh, wait a minute. Electrolytic reduction of nitrobenzene. Okay. Azobenzene is something else. Aniline is p-aminophenol. No, no. In acidic medium. Okay. Azoxybenzene. Okay. So I'm going to write the reaction. Just wait a minute. This is your nitrobenzene. For eighth question, I'm going to write. This is your nitrobenzene. If you are going to use a strong acidic medium, and this is your electrolytic reduction, so you know what will happen. This will be reduced. Basically, two oxygen is there, so hydrogen will be added towards this, and it will be converted into phenyl hydroxy. This is called phenyl hydroxyl amine, and after this, it will be in equilibrium with rearrangement will be taking place. This is your NH2, and this is your OH. So it becomes basically the last one. P-aminophenol. Rearrangement will take place. This NH2, NH is going to replace this. In this form, it will be more stable. So this is the scenario. Ninth one, you told me that the answer is A. That is correct, Humam. Austin, no answer from you. Okay. 10th is very easy. So 10th one method by which aniline cannot be prepared is hydrolysis of phenyl isocyanide. Phenyl isocyanide, that means NC, that can be reduced to prepare this, so it can be prepared. Degradation of benzamide. Benzamide will give it easily. Reduction of nitrobenzene, it can easily give. But this potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous cleavage will not give aniline. That's why it will be the answer. Please take the hint out, or if you want to have that as what do we say? If you want to write, you can write that. That's your part. Let me know when you're done with this. If you're not able to do this, just let me know. Any answer for question number 11, both of you? Reactions of amines are given, which is not correct. This is tertiary NaNO2. This will give. Okay, very good. This is secondary, sorry. Secondary it is. This is tertiary. Right? Tertiary does not give this nitrous acid, so the answer will be B. The rest, if you can check either it will be primary or secondary. Now, will you be able to complete this reaction? Any answer for this? Okay, I'm going to tell you. First of all, this M-bromocarboxylic acid is there, and you are going to react this with SOCl2. You know that when it is going to react with SOCl2, what will happen? This OH will be replaced by chlorine. So very simple it is. This is your this becomes a acyl halide like this, and bromine is as usual there. Then you are going to react this with NH3. When acyl halide is going to react with NH3, one of the hydrogen like NH2H, this will have plus, this will have minus, and you can see this will have negative, this will have positive. So it becomes amide now, and this HCl will be eliminated as a byproduct. So bromine is your there, and this becomes C double bond ONH2, and bromine is there, right? After this, in the question, it has been given NaOH-Br2. NaOH-Br2, that means Hoffman bromamide degradation. That means this product will be gone and it becomes M-bromoaniline. So I think it's very easy. It was very easy, right? N-bromoaniline. Isn't it easy?
Yes, sir.
So in the next class, we are going to complete this biomolecules. And after that, in the next week, we are going to complete the whole syllabus. So you just need to do a lot of practice and everything. I'll send the notes of D and F block as well. Please do this. Done. Okay, I'm going to tell you. This is your nitrogen donating tendency, donating tendency, donating tendency, donating. See, very simple. This is in resonance. So first of all, this is busy in resonance, and NO2 electron withdrawing group is there. So it will decrease the basicity. This is also in busy in resonance, and this is CO. Double bond O is there, which will withdraw from this. So it also have less basic character.